So the practice test doesn't have a lot of problems, but I think it's going to take a long time because there's a bunch of factoring. Um, I always try to make the test just like the practice test, and I kind of scrambled up the questions here. These are questions from section 2.2 first rather than 2.1. That's probably going to be the case on the test. In question 1a, I need to do 4 site factorings before I cancel. So I'm going to factor n squared plus 2n minus 3, searching for numbers that multiply to negative 3, that add but really subtract to 2, and that's going to be 3 and negative 1 because 3 times negative 1 is negative 3. 3 plus negative 1 is the same as 3 minus 1, which is 2. So I'm going to factor that into n plus 3 times n minus 1. And in the upper left part of my answer, I'm going to put just that, n plus 3 times n minus 1. When you're site factoring, I don't expect to see any work, but you can show as much work as you need. The n squared plus 4n minus 5, same structure. I'm looking for numbers that multiply to negative 5, that add but really subtract to 4, and that's going to be 5 and negative 1 because 5 times negative 1 is negative 5. 5 plus negative 1 is really the same as 5 minus 1, which is a 4. So that's going to factor into n plus 5 and n minus 1. I can cancel it within the same fraction or between fractions as long as I'm doing a numerator and a denominator. And I can already see that these n minus 1s are going to cancel. I need to factor n squared minus 3n minus 10, and I need numbers that multiply to negative 10, that add but really subtract to negative 3, and that's going to be 2 and negative 5 because 2 times negative 5 is negative 10. 2 plus negative 5 is really the same as 2 minus 5, which is negative 3. So this is going to be an n plus 2 and an n minus 5. And that's not going to give me any more canceling. And the last factoring I need to do, n squared plus 5n plus 6. I'm looking for numbers that multiply to 6 and truly add to 5. And that's going to be 2 and 3 because 2 times 3 is 6. 2 plus 3 is 5. So this is going to factor into n plus 2 times n plus 3. You can flip-flop the orders, those don't matter. So I'm going to get an n plus 2 and an n plus 3, and this is going to give me more canceling because I can up and down cancel the n plus 2s, cross cancel the n plus 3s. I can't cancel an n plus 5 and an n minus 5, so those are just going to be in my answer. I won't need the parentheses anymore because I've gotten rid of all the factoring in the numerator and the denominator. And this is really typical of my answers. Usually when I have these 4 factoring problems, everything cancels except one term. If on the test you start getting 2 or 3 terms not canceling, you probably have a factoring error somewhere. For part B, you're probably going to need a separate sheet of paper. The m minus 2, or maybe I don't because it's less factoring. The only thing I need to factor is this m squared plus 6n plus 9. And to factor m squared plus 6m plus 9, I need numbers that multiply to 9 and add to 6, and that's going to be 3 times 3 because 3 times 3 is 9. 3 plus 3 is 6. So this m squared plus 6m plus 9 is going to factor into m plus 3 times m plus 3. The left-hand side of part B of number 1, there's no common factors and there's no squares, so I can't factor this at all. The right-hand side, I've just factored the numerator. The denominator of m squared minus 4, that's a square with a minus. So I'm going to divide the exponent of the letter by 2. I'm going to square root the number. I'm going to get 2 parentheses. One has a plus sign, the other has a minus sign. The m's are going to be before the signs, the 2's are going to be after the signs. And again, all this factoring, hopefully a lot of you can do it in your head, so you're not just, having to go through all this side work. So let me cancel. M minus 2 top and bottom cancels. One of the M plus 3's top and bottom cancels. I can't cancel both of them. And pretty typical of what my answers are going to look like. I'm left with one factor uncanceled in the numerator, one factor uncanceled in the denominator. Problem C has 4 factorings and it's a division. Can't fit it on this page. In part C of number 1, I need to change the problem to a multiplication. To change the problem to a multiplication, I invert the fraction after the division sign, not before the division sign. When I go to factor each piece, if I go to factor the x squared minus, I'll emphasize 1x minus 6, I'm looking for numbers that multiply to negative 6, that add but really subtract to negative 1. I'm sight factoring, that's going to be 2 and negative 3 because 2 times negative 3 is negative 6. 2 plus negative 3 is the same as 2 minus 3, which is negative 1. So this guy's going to factor into x plus 2 times x minus 3. So part of my work, let me just do it down here because I'm going to be running tight on room. The numerator on the left factors into x plus 2 times x minus 3. Next I'm going to factor the x squared minus x minus 12. I'm looking for numbers that multiply to negative 12, that add but really subtract to negative 1. And that's going to be 3 and negative 4 because 3 times negative 4 is 12. 3 plus negative 4 is the same as 3 minus 4, which is negative 1. So that guy's going to factor into x plus 3 and x minus 4. And I'll put that in the left denominator. The next factoring I need to worry about is x squared minus 3x minus 4. And for those, I'm looking for numbers that multiply to negative 4, that add but really subtract to negative 3. And that's going to be 1 and negative 4 because 1 times negative 4 is negative 4. 1 plus negative 4 is 1 minus 4, which is negative 3. So this guy's going to factor into x plus 1 and x minus 4. It's going to wind up in the numerator because I flipped this problem. So x plus 1, x minus 4. I see my first canceling of the x minus 4s. The last thing I need to factor is x squared plus 3x plus 2. I'm looking for numbers that multiply to 2, that add to 3, and that's just 1 and 2 because 1 times 2 is 2, and 1 plus 2 is 3. So this guy's going to factor into x plus 1 and x plus 2. I flipped because I changed it 2 times, so it winds up in the denominator. And now I'm going to cancel up and down the x plus 1s, cross cancel the x plus 2s, and that's going to leave me for an answer an x minus 3 in the numerator and an x plus 3 in the denominator. Most of the factorings on the tests will be just like this, either squares with a minus where you just divide the exponent by 2 and square root the number, or ones that you can sight factor. All this work that I'm showing for factoring, I don't expect to see unless you need to show it. Hopefully you can just factor in your head. Question 2 comes back from section 2.1. It wants me to find the domain of a fraction. And to find the domain of a fraction, I ignore the numerator, I set the denominator equal to 0. And because it asks for my answer in words, I'm going to write those words down. I'm going to say the domain is all real numbers except And this is where the algebra comes in. Accept x equal to some number, and algebraically define the domain of a fraction. You ignore the numerator. Setting the numerator equal to 0 doesn't give a break in the graph. If you're visual, it gives where the graph crosses the x-axis. I'm going to solve the denominator equal to 0. And there's no square, so I don't have to factor. But a minus 20 from both sides. And get 2x equals minus 20. Divide by 2, divide by 2. And get x equal negative 10 for the number that goes in my answer. Back in 2.1 when we did these problems, I asked you to write your answer in interval notation and in words. If you gave me interval notation instead of words, I can live with that. Just to refresh your memory, this is not necessary, but if you liked this better, I don't have an issue with this. You could have created interval notation answers for your domain. It's not required, but it's okay to do. If you wanted to write interval notation, I'd accept that even though it doesn't ask for it. The interval notation, you'd start by creating a number line that has negative infinity on the far left edge, positive infinity on the far right edge, and any number you're excluding from the domain between, and then all round parentheses, put a u between the parentheses, the interval from, not that that's readable, negative infinity to negative 10, double round parentheses, u or union, negative 10 to infinity. That's okay, it's not asked for, but it's fine. Problem 3 exists from section 2.5. They're problems that have equal signs, so I'm going to get numerical answers. There's fractions with adding and subtracting, so I need common denominators. In problem 3a, none of the denominators have x's, so I just need to make 3, 4, and 6 into the same number, and I can make all of those into a 12. To get started with problem 3a, I'm going to make each fraction have a denominator of 12, because that's the least common denominator between 3, 4, and 6. The first fraction I'm going to multiply by 4 over 4, and that's going to make it 4x over 12. The second fraction I'm going to multiply by 3 over 3, and then after the minus sign I'm going to get 3x over 12. And to the right of the equal sign on either side I'm going to multiply by 2 over 2. That's going to be equal to 2 over 12. So in section 2.5, when it wasn't a cross multiplying problem at the end of the section, first we got each fraction to have the same denominator. Then we made a huge parentheses, put the common denominator outside that parentheses, canceled the fractions, and then solve what was left. If there was a square, you needed to set it equal to 0 and factor. If there's not a square, you get the numbers on one side, the letters on the other, and you solve by dividing, but this one just kind of worked out. I should check. There aren't any extraneous solutions that make the denominators 0 that need to be tossed, but so easy to check, I'm going to check. So I put 2 in for both of the x's in the problem, and let me just work on this left side, see if 2 over 3 minus 2 over 4, my answer is only right if I get 1/6, and I do, so I know my answer is correct. For part B, I need to factor this denominator. That's a square with a minus. I'm going to factor the denominator by dividing the letter's exponent by 2, and I'm going to square root the number. I'm going to create 2 parentheses, one with a plus sign, one with a minus sign. And that denominator, I'm going to get 2 parentheses. The x's are going to lead off the parentheses and be before the signs. The 5's are going to go after the signs, and one sign's a plus, the other sign's a minus. Usually, it matters which factor I put in first because there's only one that matches the other fractions, but here my denominators match both fractions. So I need to give the fractions on the left-hand side a chance to look like the denominators on the right-hand side. The first fraction on the right-hand side, I'm going to multiply x minus 5 and x minus 5 to make it have both the x plus and the x minus 5. The middle fraction, I'm going to multiply by x plus 5 and x plus 5. I'm going to multiply in the numerator on the right-hand side, in the denominator on the left-hand side, specifically because it just makes the denominators look the same. Not that I need to do this step right here, but what I've created is this. I have the first fraction that has x times x minus 5 in the denominator, in the numerator, and the common denominator of x plus and x minus 5. The middle fraction, which is 5 and x plus 5 in the numerator, and the common denominator of x plus 5 and x minus 5 in the denominator. And to the right of the equal sign, I haven't done anything other than factor. So now I have all three fractions with the same denominator. Make my giant parentheses. Off to the right of or left of that giant parentheses could be the right. I put the common denominator and then cancel, cancel, cancel. This leaves me with x times x minus 5 minus 5 times x plus 5 equals 14. I have a hint here. Hopefully that makes sense when I get deeper into this because it doesn't make any sense right now. Clear the parentheses by going x times x and getting x squared, x times minus 5 and getting minus 5x, minus 5 times x and getting minus 5x, minus 5 times positive 5 and get minus 25. On the left-hand side, the 5x's don't cancel. They'd have to be opposites, 1 plus and 1 minus, to cancel. Because the 5x's are both negative, I'm going to add the 5x's and keep them negative. Because there's a square, I need to set it equal to 0 and solve by factoring. I'm going to minus 14 from both sides. And when I do that, I get that minus 39 that I kind of hinted at. So now I need to factor this. I'm looking for numbers that multiply to minus 39. Apparently it's going to be 3 and negative 13 because I hinted that, because 3 times negative 13 is negative 39. They have to add but really subtract to negative 10, and 3 plus negative 13 is the same as 3 minus 13, which is negative 10. So my parentheses are going to have a plus 3 and a minus 13. Cite factoring because there's not a number in front of the squared term. And now I can just read off my answers by switching the signs. The first parenthesis gives an answer of negative 3. The second parenthesis, if I did the algebra, would give an answer of 13. I'm going to check each right on my calculator without even showing what I'm checking. I'm going to first change all the x's on the, well, let me just show you. So I'm going to check the negative 3. I'm going to see if negative 3 over negative 3 plus 5, this is checking. It's nice to check to make sure I haven't messed up. Minus 5 over negative 3 minus 5. I want to see if that equals 14 over negative 3 squared minus 25. So left-hand side is going to be fraction minus 3 over minus 3 plus 5 minus 5 over, I should say, negative 3 minus 5. Left-hand side comes out to negative 7/8. We do the right-hand side. 14 over negative 3 squared minus 25. That's also negative 7/8, so I know that that answer is correct. I'll now check the 13. To check the 13, I'll go, is 13 over 13 plus 5 minus 5 over 13 minus 5, does that equal 14 over 13 squared minus 25. I have to check both sides. Left side fraction, 13 over 13 plus 5. Out of the denominator, minus fraction, 5 over 13 minus 5. Left side comes out to 7 over 72. Now I'll work on the right hand side. Right side is 14 over 13 squared minus 25. And I get that same 7 over 72. So I know both of those answers are correct. There aren't any extraneous solutions on the test that you have to worry about. Part C, I'm just going to cross multiply. I'm going to cross multiply up and get 4x. I'm going to cross multiply down and get 3 times x minus 10. This is going to give me 4x equals 3x minus 30 when I clear that parentheses going 3 times x and 3 times minus 10. Now I'm going to minus 3x from both sides. That's going to give me x equals minus 30. And I believe that checks just fine. And on the cross multiplying, those don't introduce extraneous solutions. I have an answer key off to the side here that I printed out that I haven't been looking at, that I probably should be looking at to make sure that I am not writing something down wrong, but that feels good because that's right there. For A, it asks me to reduce a fraction. It doesn't have any adding or subtracting, so I don't need to cancel. I'm just going to take the 14 divided by 2, the 16 divided by 2 to reduce the fraction. 14 over 16. 14 over 2 is 7. 16 over 2 is 8. And for the x's, I have 2 x's in the numerator from the x squared. 7 x's in the denominator from the x to the 7th. If I cancel, I'm left with 5 x's or x to the 5th in the denominator. What I really should have done is just said, I can shortcut this without expanding. Take the bigger exponent of the x minus the smaller exponent. Leave the x where the bigger exponent is. And for an answer, I should get 7 over 8x to the 5th. Can't really draw that x out to the right of the fraction. I can only do that if it's in the numerator. B is ugly because it's the only grouping factoring on the test. So let me factor both the numerator and the denominator. I'm going to start off and I'm going to factor 3x squared minus 8x plus 4. There's one of these on the test, bad factorings. I'm going to multiply the 3 and the 4 and get 12. I'm looking for numbers that multiply to 12, that add to negative 8, and my template says they're double negative. So it's going to be negative 2 and negative 6 because negative 2 times negative 6 is positive 12. Negative 2 plus negative 6 is negative 8. So the negative 8x, I'm going to make negative 2x minus 6x. And I'm going to rewrite this problem. I'm going to have 3x squared minus 2x minus 6x plus 4. Introduce my parentheses. Put the negative inside the second parentheses. My first parentheses I factor out an x, and I'm left with a 3x minus 2. My second parentheses I factor out a negative because the first term is negative. I factor out a 2 because the numbers have a common factor of a 2. And the inside of my parentheses need to be the same, so I didn't even think, I just copied. And for my factoring, I need 2 factors in either order, a 3x minus 2 and an x minus 2. The other factoring, the x squared minus 5x plus 6, I can sight factor. I need numbers that multiply to 6, truly add to negative 5, and it's going to be negative 2 and negative 3 on my template. This is the double negative part. Negative 2 times negative 3 multiplies to be 6. Negative 2 plus negative 3 adds to be negative 5. So when I factor this, one parenthesis is going to get a minus 2, the other is going to get a minus 3. Doesn't matter which order that I put them in. And now I can cancel the x minus 2's. For an answer to part B of number 4, I'm going to get 3x minus 2 over x minus 3. C is just a factoring and canceling. In C, I need to factor x squared plus 3x minus 4, which hopefully you can just sight factor. But if I can't, I'm looking for numbers that multiply to negative 4, that add but really subtract to 3. And that's going to be 4 and negative 1, because 4 times negative 1 is 4. 4 plus negative 1 is the same as 4 minus 1, which is 3. So that's going to factor into x plus 4 and x minus 1. Should be writing equal signs because that's equal to the line above it. This x squared plus 6x plus 8, when I go to factor it, I'm looking for numbers that multiply to 8, double positive, add to 6. That's going to be 2 and 4 because 2 times 4 is 8, and 2 plus 4 is 6. That denominator is going to factor into an x plus 2 and an x plus 4. I'm going to cancel the plus 4's, and I'm going to be left with x minus 1 over x plus 2. At 26 minutes, that doesn't look like a 2. I think I'm going to pause and make a part 2, just because there's, 4 problems left. It's probably going to take me like 14 minutes, and I don't want a 40-minute video, just in case this isn't readable. This is x minus 1 over x plus 2. So I'm going to pause and I'll do a part 2.